So welcome to the coffee lecture today on SpringerMaterials database. It's coffee lecture number 30. We've done it a couple of times and we repeat it regularly because it's a very nice and very important database in a field of materials, but also chemistry. So here I have a slide where I dare to write down that this is absolutely world's largest database of curated physical and chemical properties. And inside this database, we do not have only molecules and atoms as classes, but also ceramics, alloys, polymers, and multi-phase systems. For that reason, there are different people interested in the SpringerMaterials database: chemists, material scientists, physicists, and I think that's these are the most important fields. It all started actually with the SpringerMaterials database in 2009, but the collection of data, which is the heart of SpringerMaterials, is London Bernstein. And this has been founded in 83, so really far back. And it has existed as printed books for a really long time. We have the printed collections of London Bernstein also in the Infozentrum. Now, over the years, as you can see on these graphics here on the right-hand side, SpringerMaterials included also other databases, not just London Bernstein, but also Linus Pauling files, which are for phase diagrams and inorganic solid phases. There's a lot of thermophysical properties of pure substances and mixtures. I'm gonna make a little demo about that. You can find in SpringerMaterials absorption isotherms, data on polymers, and in the last years, they're including even much more data, recently data on battery materials, inorganic perovskites, and other things, which you will see. So from here on, I'm gonna do a live demo. So in order to access SpringerMaterials, you need to be within the ETH network. It's licensed by the Swiss consortia. And here I am already on the landing page. So what you can see is that it is actually a very simple starting page. You can type here the name of your molecule, the name of your material. You can search with elements. You can do a corrosion search. I'm going to show you a little bit of that. And then on the left-hand side, you see these different collections that are part of SpringerMaterials database. And here below, you actually see this London Bernstein series in electronic form. So if you click on London Bernstein bookshelf, you see all those volumes, which you also have in the library. And for example, in group 4, you have physical chemistry, and you have here then all those documents in PDF formats. And then you can search for data. Now, as you can imagine, having a database just full of PDF, static PDF documents where you can search for like that is not so attractive. That's why they've decided to build a special tool to extract data from London Bernstein bookshelf into so-called SpringerMaterials Interactive. And in SpringerMaterials Interactive, you have really, really many different physical properties available in a digital format, so to say. You can visualize those properties, and you can also download the data. And I would like to quickly show you what we have here. So these are different properties that have been extracted from London Bernstein so far. It's not all the properties yet, but we have for semiconductors 60 different properties that you can look into. We have dielectric constants, we have some NMR data, and then lots of mechanical properties, optical properties, this refractive index. Here are absorption isotherms. So if you click on that, you get like over 2,000 different absorption isotherms. And then we have thermophysical properties also. So for example, I can show you viscosity, how this looks like. So if you click on viscosity, I will first close that just to demonstrate that we have what we have always available is viscosity, so the property for pure substances, and then for mixtures. And in particular, that part for the mixtures is very, very valuable because it's hard to find data for different mixtures. Now, if just for the curiosity, we have here for pure substances, we have almost 4,000 results. And for the mixtures, we have over 4,000 different mixtures and their viscosities. So let's have a look, for example, at a mixture of methoxypropanol and water. So that means we have now here different concentrations. And if I click on view, you get a plot where you have dynamics viscosity as a function of system temperature. For those mixtures, you can also put it as a function of mole fraction. And then you get the plots for different temperatures. What is nice is that all those data that we see in the plot are down here in the lower part, and you can download them. Yeah, so you can download it as a CSV file. And here you can then also see where they come from and who's been responsible for that data. This I always show because the data in SpringerMaterials has been looked through by a professional always. It's not just extracted from somewhere with AI tools or whatever, it's always been evaluated. Another functionality that we have is here compare substances. So I could in principle search for another mixture. Now, I don't know if I really, this sometimes takes a little bit longer. Let me see. Let's say that mixture and add it on the top to see how the property changes. If I take instead of, in this case, instead of water, I took methylpentanone, yeah, and then the viscosity went down, it got more viscous. Okay, so that was an example of SpringerMaterials Interactive, which I very much recommend if you're searching for specific properties. Then, if your search is different and you're starting with a molecule, as for example, I'm going to take something really simple now, 1-propanol. You can just type the name up here. You can also put a formula if it's not too complex. So very complex organic molecules, it's not a place where I would go. So it's for simple molecules. And what you see then, the first result is called substance profile. And in substance profile, you then find under properties, really all the properties that are available for this compound within the database. And this is important because not all of those properties that you see here have been already extracted in Springer Interactive. There you don't find everything. A typical property, which I often had to search in the past, was self-diffusion coefficients. You will not find self-diffusion coefficients in Springer Interactive. You have to go here, and then you click on self-diffusion, and then you see that's a document from London Bernstein. You click on that, download chapter, and then you get to the PDF, and here you then have all the diffusion coefficients measured with different methods at different temperatures. And if you want to see the reference where this comes from, it's all listed here. Yeah, so this is then how it used to be. That's how SpringerMaterials was when I started working in InfoCentrum. It was everything was like that, PDF documents, and now we have this SpringerMaterials Interactive as well. So yes, so if you have a molecule you would like to search for, just put in here its name, and then it should work. Then I would like to show you very briefly an example what element search is. This is for those who are interested in element systems or alloys. So if you would like to explore, let's say, phase diagrams of iron-nickel systems, you can go here to element search, you type on iron-nickel, and then you see here matching element systems on the right-hand side. This is the one I'm interested in. And then again, you first get these substance profiles. In substance profiles, now iron-nickel is a very well-known system, so you have here system elevation reports even, and phase diagrams are then listed right here. And so, for example, if you're interested in one of them, you can just check. These are all, you can move around and see what the phases are, and you can download them. And then you have lists of phases here with links to the crystallographic data sheets. So if you want to see specific phases and their crystallographic data, you can you have all this available. Even the interactive structure is available now. Obviously not, doesn't work on this computer, but you would get here the unit cell picture. That's one thing. Then corrosion search I will not do. It's very trivial. You just search for materials. What I would like to say in the last minutes is that you can see here latest developments. And I'm showing you that just to tell you that this is really a very lively database. There's a lot happening. So the last thing that has been done is extraction of battery data from different journals with AI tools. And then this has obviously been done with Professor Liu from Texas. And then this data has been verified and added into the SpringerMaterials here as battery materials. And this is really new. And you can then look, for example, for battery materials, volumetric properties. And you then have here, in this case, capacities and the value and where it comes from. And up here, you then have efficiencies, electric conductivities, energy, and voltage. So this is very new. And again, SpringerMaterials allows to download that data. And there's more. There's been a lot of data on perovskites added in the past year. So here, if you click on that, you then get information on specific perovskite. And again, you can download all this and synthesis method, systems description, all kinds of things. So these are newest data that have been added, and ionic liquids as well. If you search for polymers, you just try with the name up here. So PMMA would be polymethacrylic acid and so on. Now, let me go quickly down here. In the bottom, you have a link to video tutorials, which I would like to mention. So if you click on video tutorials, you come to the page of Springer Nature, and then you need to go to databases. And once you go to databases, you scroll down a little bit, and you get to SpringerMaterials. And here you have then quite some videos on how to do different kinds of searches in SpringerMaterials. Also, if you're interested in semiconductors, for example, there's a video about that and absorption, crystal structures, and so on. So that is something what I wanted to mention. And yeah, with that, I am actually already finishing. Let me go back. I've prepared a coffee lecture card, which you can download from this site. And we go back to the presentation modus. And what else? This is the last lecture in the second week of our 33rd series. And next week, we have again a nice mixture. One is Science of Synthesis for Inorganic and Organic Chemists. On Tuesday, we start with that, with Leo Betchout. And then we have something for biology, Cytoscape. And we finish with a very, I think, entertaining and nice lecture on why we like and why we don't like Mendeley. So I will say join us because it's going to be fun. Thanks a lot for attention, and I'm happy to show you more if you like.